we discussed question 9 for A-Level Mathematics 1, paper 1, May or June of year 2020. You're given the equation of a curve. Y is the cube of 3 minus 2x plus 24x. And you're asked to find expressions for dy dx and d2y dx squared for the first part. For this case, to find dy dx, you need to differentiate the function y. And look at this function y here. That is actually 3 minus 2x cubed plus 24x. You have a power function, so you need to apply the chain rule, bring the exponent down, and you have 3 minus 2x, reduce the exponent by 1, and now you need to differentiate the inner function, which is 3 minus 2x. The derivative of 24x is 24. The derivative of this part here, when you differentiate 3 minus 2x with respect to x, that gives you a value of minus 2. And then minus 2 multiplied by 3 here is negative 6. 3 minus 2x squared plus 24. And that is the expression for dy dx. To find d2y dx squared, differentiate dy dx once more with respect to x. Negative 6 is just a constant, so differentiate this expression, bring the exponent down, reduce the exponent by 1, and now differentiate the inner function again. From the previous part, you know that it is negative 2, and the derivative of 24 is 0. So negative 4 times negative 6, that should give you 24. So when you multiply these together, you have 24 times 3 minus 2x. And that is an expression for d2y dx squared. Part B, find the coordinates of each of the stationary points on the curve. In order to do that, we set dy dx to 0. Then negative 6, 3 minus 2x squared plus 24 must be 0, or 6, 3 minus 2x squared is 24. We can divide throughout by 6 so that the square of 3 minus 2x is 4. Taking square root on both sides, we have 3 minus 2x equals plus minus 2, or 2x is 3 plus minus 2 here. Then 2x is either 1 or 5. 3 minus 2 will give you a 1, and 3 plus 2 gives a 5. Divide throughout by 2, and x is either 1/2 or 5/2. The coordinates of each stationary point. You have stationary points at x equals 1/2 or 5/2. Now we need to find the y coordinates. So when x is 1/2, you need to find the y value. You replace it into the function here. Then you have 3 minus 2 times 1/2 squared plus 24 times 1/2. That will be 3 minus 1, which is a 2. And then when you, sorry, this is a cube here. When you raise it to the 3, you have an 8, and that is a 12. So y here is 20. Then one of the stationary points has coordinates 1/2 and 20. This will give you one stationary point. To find the second stationary point, you replace x with 5/2 into the function given to you. So you have 3 minus 2 times 5 over 2 cubed plus 24 times 5 over 2. So that 2 cancel off. You have negative 2 to the 3, which is negative 8. And then that will give you a 12 times 5 is a 60. So you end up with 52. The coordinate of the second stationary point is 5 over 2 and 52. That is the second stationary point. Part C, you need to determine the nature of each stationary point. To do that, we can use the second derivative test because you have an expression for the second derivative. So the nature of each stationary point, you have to determine whether these points are maximum or minimum. Using the second derivative test, we evaluate d2y dx squared at x equals 1/2. So that gives you 24. 3 minus 2 times 1/2 here, that will give you a value of 48. This is greater than 0, meaning that the curve is concave up for a second derivative greater than 0, and you have a minimum point. Therefore, 1/2 and 20 is a minimum. For the second stationary point, we evaluate d2y dx squared at x equals 5 over 2. So you'll have 24. 3 minus 2 times 5 over 2. That cancel. That is a negative 2. And you have negative 48. This is less than 0. When the second derivative is less than 0, you have a graph that is concave down. That gives you a maximum point. Therefore, 5 over 2 and 52 is a maximum. Question 10. You are given the coordinates of 2 points, point A and point B. AB is the diameter of a circle. Part A, you need to find the equation of that circle. Now let's look at this circle here. So for this circle, it has a diameter AB. This is not drawn to scale, so it doesn't really matter. It has point A with coordinates -1, -2, and there is a point B here with coordinates 7 and 4. To find the equation of a circle, we need the center of this circle and also the radius. The center is the midpoint of AB. So the center is the midpoint of AB. To find the coordinates of the midpoint, we average the x coordinates and the y coordinates. So you have 7 plus -1 divided by 2, and also 4 plus -2 divided by 2. Then the coordinates of the center is given by 3 and 1. To find the radius of the circle, we see that the radius is the distance between the center and point B. Now, if you are given 2 points here, let's say point A has coordinates x sub 1, y sub 1, and point B has coordinates x sub 2, y sub 2. The distance between point A and point B is the positive square root of the sum of squares of the difference here. You subtract the x coordinate, square them, and you subtract the y coordinate, square it, and then you add and take square root. That is the distance formula. To find the radius of the circle here, the radius is actually the distance between the center and point B. You can use point A as well, doesn't matter. Then for the x coordinates here, 7 minus 3 squared. And for the y coordinates, you have 4 minus 1 squared. So that is square root of 7 minus 3 is 4. That will give you a 16. That is 3, that is 9. So that gives you square root of 25, which is a 5. Radius is 5. And you also have the center here. This is the coordinates of the center. Then the equation of the circle is given by x minus the x coordinates of the center, square it. And then you have y minus the y coordinate of the center, square it. And that is 5 squared. So you can write this as the square of x minus 3 plus the square of y minus 1 equals 25. That gives you the equation of the circle. Part B, you are asked to find the equation of the tangent to the circle at the point B. So that circle has a tangent at point B. Say this is the, let's say this is the tangent line. So for this tangent line here, it touches point B. To find the equation of the tangent, we need the slope of this line. You can find the slope by finding the derivative, but it is not necessary. The slope of this line is perpendicular to the slope of AB. In fact, AB is a normal line at point B. So first of all, we find the slope of AB using the slope formula. So you have y2 minus y1, 4 minus negative 2 over 7 minus negative 1. That will give you 6 over 8, which is 3 over 4. That is the slope of AB. The slope of the tangent is the negative reciprocal of the slope of AB. So that is negative 4 over 3. And the tangent line passes through coordinates, point B with coordinates 7, 4. Then the equation of the tangent in y minus 4, that is negative 4 over 3, x minus 7 here. To make your life easy, you can multiply throughout by 3. When you multiply throughout by 3, you have 3y minus 4 equals negative 4x minus 7. So that 3y minus 12 is negative 4x plus 28. You can move the 4x over and 12 as well. So that 3y plus 4x, that is 28 plus 12, that would give you 40. And that is the equation of the tangent. Part C, find the equation of the circle, which is the reflection of circle C in the line T. So this is the line T. You need to reflect this circle over that line. So when you have a reflection, then that circle goes here. So you have a circle here, and B here is actually the point joining these two circles. But if you look at this, to find the equation of a circle, you need the center and the radius. And you know that the radius is the same as the original circle, which is 5. There's no change in the radius of the circle since it is a reflection. But you need to find the center here, the new center. So to find the new center, let's say this is O prime here. This new center and that O center has B as the midpoint. So you can see that B is the midpoint of the line segment joining the O center and the new center. So if B is the midpoint, let's say the new center has coordinate x and y. Since B is the midpoint, then 7, 4 here must be the midpoint of these 2 points. The O point has coordinates 3 and 1, so you have x plus 3 over 2, average the x coordinates, and then you have y plus 1 over 2. That from here, x plus 3 over 2 must be 7, so that x plus 3 is 14, or x here is 11. That equates the y coordinates. Y plus 1 over 2 is 4, y plus 1 is 8, and you have y equals 7. The new center of the circle has coordinates 11 and 7, and the radius is 5. So the equation of the new circle here is given by x minus 11 squared plus y minus 7 squared equals the square of the radius 5 squared, and you can write this as the square of x minus 11 plus the square of y minus 7, which is 25. And that gives you the equation of the new circle.